But now we were now let's in the root directory we have a data directory, and we go inside. We don't have, so let's create two more subdirectories inside that. I will put MapReduce, and then stock. Okay, input. I'll say input, and then I'll say stock data. I'll create this subdirectories inside the data directory. And then I will copy this. So I will use -put command, and we have the file in the home directory. I guess I'll use so sdfs dfs and -put command we are using, and we have to give the source path of your file. So basically home data making and the sample not sample my. Where did I copy? Okay, so it is in work area. Okay, work area data input. Okay, this is our source directory, and we are copying into the SDFS directory data MapReduce input and stock data. So I am going to just run this command. It's running. It is copying your file, and I will also open in my local the SDF's name node web UI 192 162 198 192.168.27.6. I'll go to browse file system. Here it is copied. There are some warnings are there. Just ignore for now. And you go to the data, MapReduce, and stock data, and this file is copied here. It's around 327 or 377 or 328 MB of data. If you click on this, you will see the block information. This file is converted into 3 blocks. So the block ID is ending with 825, and the second block is 26. Third block is the ID ends with 27. Right. So first block was around should be 180, 128 bytes MB megabytes. It's actually it says 134. Basically, it will be close to 1.8, or we have to see what is the block default block size. Okay, so and then uh, other block also will be of same length, and the remaining one, the last block is the remaining length. Okay, so if you want to check the default block size, uh, for SDFS. Block size. There is a one property, a DFS block size. Okay, so there will be a there will be there will be a property called uh, DFS block size. So whatever the value you provided here, so based on that it will split it. So basically, I think it is shows this number. That's why we saw split it into that many number of bytes. Okay. So you understood, right? So basically, our file is converted into 3 blocks.
Yeah, pretty yeah.
Yeah. Now this is we saw in a HDFS. Now we'll just show in the name node directory what are the change it got made. We'll just see it here also. In the data node, you see it here. Data node directory. Nothing is there. Uh, and name node. Name node current directory. There is a file called edits in progress. There's one file called file created called edits in progress. This will have this information, some metadata here. Okay, so we'll explore. I'll explain you all these files a little bit later. So we saw our file is converted into 3 blocks and stored in HDFS. Okay. Now what we'll do is this is right. This is done. Okay. So next is we talk about MapReduce. So SDFS is more of you need to understand how the distributed file system works. So when you store a file, how this is how many blocks this is converting and other stuff. How the replication factor is handled. So like what is the replication factor it is set. So and what is the block size. All this information you need to know. Once we learn SDFS, now our next step is to process this data. So we stored our data into HDFS. Okay, it's stored in stored as a different converted into different blocks and stored on the HDFS. Next step will be how to process this data. Okay, so process this data in parallel using a MapReduce framework. So MapReduce framework uh, is a new programming model. Okay, so basically it's not a programming language, it's just a kind of programming model how your data can be efficiently processed. Okay, so that you can make use of the distributed computing and our parallel processing. Since our data is splitted into smaller size smaller pieces, or you can call it as blocks and chunks. So how do you process those chunks independently so that we can run the computation in parallel? Okay. So example, we have this 3 blocks, block 1 and block 2, block 3. So let's run our write a MapReduce code and process this block 1. So because this there's nothing connection, right? Basically, this might have, say example, if this file has some 300 records or lines, so it is going to for just for simple logical logically, if you think this is going to have some 100 uh, records or 100 rows of data, this is going to have hundreds and this is going to have 100. So let's do the processing on this 100 and get the result, and this 100 and this 100. So we can do the job in parallel, and then finally we can actually combine combine the results and get the result. So in way you can actually does parallel computing and you can get the result. So that's how the idea of MapReduce works. So it runs in two phase. Okay, one is a map phase, and next is the shuffle phase. In between there is a phase called shuffle phase. So this is whatever we write code that will be run on one for map phase we'll write a code, and reduce phase what code has to be run on map phase we'll be writing on the there is a method called map method. I will actually will go to the program and I'll explain detail. So there will be a method called map method where you go and write your logic. So that logic will be run on map phase. And similarly there will be a method called reduce method, and where you write a sum code that will run it on reduce phase. And shuffle phase generally the framework does this shuffle and sort. Okay, so that we don't write any code for that. Okay, so what do you do on map what is the code you write on map task, and what is the code you write on reduce task, I will explain you. But at high level, uh, so there will be a map task which runs in parallel and process your individual blocks. Okay, so if I just expand this image little bit, this is the name node, and we'll have three data node. So this data node 1, and this is data node 2. This is data node 3. So we actually stored B1 block 1 here, and um, block 2 here, and block 3 here. Okay, so when we write a when we write a MapReduce job, just give you I will high level I'll explain you, but I'll also explain you the code to get more understanding. MapReduce job, we express our logic in two different methods. One is a map method. So this will be inside your mapper. Okay, you can just think there is a program called mapper which has a map method. So whatever you code right on this map method, okay, map method or function, you write whatever the functions, whatever the code you write on this map function, which is part of your mapper code, it is going to run. This program is going to run, and you will have similarly you have a reduce function or method. Reduce. So this will be in the program called reducer. Okay, so here I write some code here. Okay, and we write some code here. Okay, so when we submit this job to the resource manager. Okay, so when we submit job to the resource manager for the, because that is the one is maintaining the resources. Okay, so for storage related things we contact name node. For job computation related things we communicate by through the resource manager, right? So when you submit the job to the resource manager, it is going to take your job, okay, run this mapper program and reducer program on your slave nodes. So how it is going to run, what it does is, first it is going to so the job when it running on this data nodes or the slave node, is going to run as a map task and reduce task. So your job will be converted into map task and reduce task, and will be running on this slave node and processing your blocks, individual blocks. Okay, so I will take this, I will represent like something like this. Okay, so first mapper program only will run. First is a mapper program will run. The second is a reducer program will run. So when you run a mapper program, so example I consider this is mapper one, and you will have a maps task inside that. So map task for your mapper one will be running here, and mapper 2, which has again the map task, mapper 3, and you have map task. You can ask me uh, how many mapper tasks we have to run, how it is decided. The simple equation is how many number of blocks you have. So basically, okay, one thing I left it. Uh, you will also say that what is my input location, input file location, where I want, which the file which I want to run with this program. Okay, so this logic has to be run on this particular file. The files which are available in this location, this logic has to be run. Okay, means the processing is, we are going to process the input file with this logic, and you need to specify which location you need to output file location. Okay, once you pass this mapper program and reducer program with what is your input and output location, okay, so what it is going to do, it is going to look for the resource manager, look for the input location. It asks for the name node, uh, where is this blocks for this file is located. Okay, so it looks for the, it asks the name node to get the block information, uh, where these blocks are located in your data nodes. So the name node will give you the block location, and the resource manager will schedule your job to the respective data nodes wherever you have the blocks. Now, the how many number of mapper is mapper or map task is will be running is based on the number of blocks for your file which you are passing, which you are actually going to process. Okay, all this mapper tasks will run in parallel. Why? Because the individual blocks are, there is no dependency between these two blocks, right? So basically this has set of lines or rows. This mapper task will run on this file and generate the output. Similarly, the mapper 2 will run on this file, will generate the output. Similarly. So the once this the intermediate data means the output of the mapper will be written into your disk on individual data nodes. and then this is called map phase. Okay, so you take an individual block and apply your logic which you written on map task to this that file and generate the intermediate output. So once you get the intermediate output from different mappers, and the output of intermediate sorry output of the each map task will send it to this next phase called the reduce phase. Okay, so this one is one phase, this second phase. So this we call it as map phase, and this we call it as reduce phase. I just okay. So I'm sorry. So there was some background noise. So basically, so map phase individual block is the mapper is run on the individual blocks and generate the output, and then the outputs of individual mapper is sent to the reduce phase. Okay, during that time, while sending the data to the reduce phase, the data will be grouped based on the keys and sent to the reducer. Okay, uh, then the reducer will get the uh, so you can actually decide how many number of reducer you want. We cannot decide on the mapper because the mapper is or map task is equivalent to number of blocks. The reducer is more of aggregating or combining your result. Okay, so the reduce phase we can decide. Say example, if you want only one reducer, you can just go and configure I want only one reducer. So example, that reducer, if I think I want to run it on this node. Okay, so the reducer can be run on any node. Okay, so that will be decided by the resource manager. So if say example you are only one reducer you want to run, then it will choose any one of the node. Okay, say example I choose this node. So reducer will be with the reduce method will be running here. So your output from individual map task will be sent to this reducer, and whatever you logic written on reduce method will be running on these outputs and give you the result. That's how the MapReduce framework works. I will show you. So you see here that there is a data sitting on HDFS. It reads by the map phase and does the calculation and give it to the reduce phase. During that time, there will be shuffle and sort. Shuffle and sort basically does your groups your key and then does the sorting and give it to the reduce. When I say key, right? So in the map reduce, everything you can actually process in terms of key value pairs. Even though I pass this content, right? So I just opened the one which we were copied. So I merged some of the smaller files into bigger files. I will show you one file content. So you see there is this New York Stock Exchange data has this information. So the first line is more of column information about the data, and from the second line you see the stock symbol. Sorry, this is the exchange, which exchange it is coming from, New York Stock Exchange, and the stock symbol and the date, timestamp at which or date at which the trading is happened, and then the what is the stock's open price, the what is the that day's high price and the low price and the closing price and some stock volume and the stock adjusted price. So these are the values it has. Now when we process this data in map task, so you are going to get this values or these lines are key value pairs. When I say key value pair, key is basically your kind of offset number, which is your kind of, think of as an offset is line number. For simplicity's sake, it is going to get the key as a line number, and the entire value, entire line is in a value, as a value field. So in MapReduce, everything you can express as a key value pair. Okay, so that's a fundamental abstraction it has. So all the data will be expressed as a key value pairs. So those key value pairs. Okay, so those key value pairs will be sorted, grouped by key and sorted. Then it gives the final grouped key, the key with the grouped values. It will be given to the reducer. Then the reducer will do logic, which what you written, mostly the kind of aggregate logic you would have been doing, and finally you write into STFS. So this is how the MapReduce internally does. So this is what I just put it in different blocks. You will have block here, and I'll tell you about what is input split. So you will have HDFS block, and for each HDFS block you will have a mapper running on map phase, and you will have a shuffle and sort phase, and the result will go to the output of this. Result will be shuffled and sorted and shuffled, and sent to the reduce phase. After aggregation done, it just write into STFS. Okay, so do you have any question till now?
No, Pari. Pari, actually, if all the three node like block 1, block 2, and block 3 are related, like for example, I'll go to relational database system, right? Employee table.
Okay. Yeah.
So my employee manager ID, it can stay either of the blocks, right?
So basically, this we are talking about single data set. We are not actually
Okay.
this. So yeah. So joining between two data set, there is a option to
Okay.
do that, but
Okay.
initially we start with the single data set.
Okay. Okay. Fine. Yeah.
So when we okay, we can do join between two data set. That's there are some options are available, but
Okay.
even when you do join also, for you, every time you actually work, when you maybe when you work on the as a block, right? That block is comes from the only one data set, not the two data set. So yeah, that's what. So we can actually do the join. There is option, but it's more of your employee data. Means as per your example, your employee
No.
data will be in block on block two. The
No,
manager
but
details use. Yeah,
yeah, yeah. Okay. So one file I have employee details.
yeah,
So in the same file I have because manager is employee, right? So
correct.
okay. So employee manager data might lie in B3. So in this case, so all will be in the reduce page. It will be taken care, or it will be in the mapper.
No, what is the like? It's based on how what is the process you want to do.
Okay. Okay.
Okay, so if say example, okay, we'll consider this example. We'll actually will try to do more scenarios. Will just I'll explain you this scenario. Okay, so example, okay, or maybe you can consider one more scenario. Okay, I have any implied data? Yeah, I have some implied data. Okay, so I have this employee data. Okay, so I have just for simplicity's sake, I have only 20 employees. Okay, now what is, so when I store this data into HDFS, so so based on size, it is going to convert it as blocks and others. So you'll have a number of blocks based on your size of your file. Okay. Now, so example, we take as the same example. So we think as it's converted into 3 blocks. Okay. So say it took, I'll just take this, explain it here. So it's 20 rows are there, right? So example, first block is taken 8. Uh, okay, I'll just do 6. Something like this. Okay, any random distance thing. So so first 8 records or rows are stored on the blocks, because the file will be converted to 3 blocks for just assumption, right? 3 blocks.
Yeah. Yeah.
And the second set of rows are stored on the block 2. And third, okay, so I'll just put it down. And this is block 3, right? Now I'll take first scenario, I'll explain you, but you can ask me few more scenario, then will based on that we'll do discussion. My first scenarios, so I have 3 blocks. What I want to use, I'll write a MapReduce program. I'm going to write a MapReduce program just to find out uh, uh, a department wise. Okay, so I have a department here: admin, manage, admin, sales, and tech, I guess, right? Or this is the,
Yeah.
yeah,
Yeah.
this is, get
Yeah.
it? Or no, not a department. I think this is a
Job.
destination. Okay, job
Yeah.
destination.
Job.
So you see the department A, B, and C is
See.
there. I don't see D. Okay, so 3 departments are there: A, B, and C. Okay. Now I want to find out the uh, total salary which is paid for the department wise. Okay. It's just this simple query: select department name, comma, sum of salary from EMT table, and group by. So this is the query I want to run. Okay, means I want to find out if I run this query, what I will get. That's what I want to write it as a MapReduce program. Okay, I want to achieve each department. Say example, take this month. So end of February, end of the end week of the February, how much salary I have to pay for each department. If you want to find out that, this is a simple query you run on SQL, right? Okay, so if I want to achieve the same functionality in MapReduce, what I have to do? So basically, I have to say example, I get some. Um, So some numbers will come. Say this will be, can be some 5 lakhs. So this can be some 8 lakhs. And this is some 9 lakhs. Okay. So so this is the output finally. Okay. How this say example, when I ran this query, this is the output you get. Okay. In MapReduce, how to achieve this? Okay. Now we'll discuss about this. So we have 3 blocks. Okay. So I told you 3 blocks will have a 3 mapper. So in the mapper method, what I need to do is, so what I will get a map method input. Okay. So there is, I told there will be map method. So this will have some input, right? Method will have arguments. So it says key and value are the inputs. Okay, this method is have key and value, and there will be one more context. Okay, I will tell you what is the use of context. So for simplicity sake, you have a key and value. What is a key is, as I mentioned, line number is a key. When you read the lines from blocks, it is going to give me the key as a line number and value as the remaining the entire line. So I get key as a line number, just say 0, and key as this, and value as this entire line. So the map task, okay, the map task will get called for every record in your block. Okay, so every record in your there will be a mapper. We have a mapper program which will run, and the map task will be called for every record in your block. So the block has 8 rows or 8 lines. So 8 times the map task will get called. Okay, so what I am interested is, I am interested on this department and the salary. This because my aggregate is based on department, right? And I want to do the sum of the salary. So what I am interested is, I am interested on those two fields. What I'll just do, I will make the I got the key and value as argument. When the input comes to the map method as a key value pair, the output of the map method also key value pair only, because I told you in MapReduce everything we express as a map key and value. Okay, so I'll just split this line by comma separator, and I'll pick the last two values. For example, if I split this, then I'll get an array, right? Or I'll get an array. Firstly, this example I store this into a line. So when I do split of dot, I'm going to get an array of these many numbers. Okay, it's going to stop it. Please rejoin with the same link. Once we explain, then we can wrap up. Okay, just rejoin the same link, please.